Well, hello, algebra students and seekers of truth. We will continue our study of inequalities with two special cases. Sometimes you solve a problem and we expect there to be an answer, a clean answer, maybe a messy answer. But sometimes we solve an inequality and there may be no solution at all. So we're going to see some examples of that. And when we say no solutions, that means no matter what variable we put into the inequality, it'll never work. So no value could make the inequality true. And sometimes we solve an inequality and the solution is all real numbers, which means that all values, like you can put anything into the inequality and any number that you want into the inequality and it would still be true. So let's get right to it and let us look at an example here. So number one, 3p minus 5 is greater than 2p plus p minus 7. So before I go further, I am going to start out by combining my like terms here. So that gives me 2p and 3p added together. That gives me 3p and then negative 7. And everything else is going to be exactly the same. So 3p minus 5 is greater than 3p minus 7. Then what we're going to do next is subtract. We have to get all the variables on the same side. So let's subtract 3p from the left. And when we do that, we have to subtract 3p from the right side. And so what you end up here with is 3p and negative 3p cancel. And what you end up here is negative 5 is greater than 3p and negative 3p cancel, and that's negative 7. Okay, but this statement here is incorrect. It's a contradiction. Negative 5 is not greater than negative 7. So this is what we mean when we say there's no solution. Right? So you end up with an impossible statement. Okay, there's nothing that you can put into this variable for this inequality to be true. So we say no solution, and there's really nothing to graph when you don't have any possible solutions. We don't have to graph anything. All right, now let's continue on and look at another example. So this is also a complex inequality, a complicated problem, variables on both sides. So let's start with the left. We're going to distribute the 6, and that gives us 6x. And then 3 gives us 18, which is less than, and everything on the right is the same, 5x plus 18 plus x. Then we should combine our like terms. So we have 5x and x. That together gives us 6x, and everything else in the inequality is the same. 6x plus 18 is less than 6x plus 18. So now, when we let's work out all of the details here. So we subtract 6x from both sides. And the 6x's will cancel, and we get 18 over here, and then this less than symbol, and then 18 over here. So now we get another nonsensical statement that 18 is less than 18. So, this is of course not true. 18 is not less than 18. It's equal to 18. Okay? So again, this is no solution. There's nothing that you could put into this problem that would make it true.